Okay, in this case, you've got a cherry here that's fallen off the tree, or the bush. I'm not sure if a cherry grows on a tree or a bush. But either way, it starts off after 0 days on that first day at 20 grams. Now, since it's not receiving any nutrients, it's going to shrivel up a bit. So after 1 day, it actually reduces in mass down to 19.9 grams. After 2 days, shrivels up a little bit more down to 19.2. So that's after 2 days. Now after 3 days, it's kind of increasing the rate at which it's shriveling here. 17.3 after 4 days. It's really deteriorating, 13.6 grams. And after 5 days, it's really reduced here to 7.5 grams. So if X is the number of days and f of x is the mass of the cherry. Okay, we got a boat here with 2 people, and the original mass of the boat is 60 kilograms. Okay. Now, we're measuring in minutes here. So after 30 seconds, or a half a minute, right? That's how long it takes one guy to get on there. And now the mass of the boat is 140 kilograms. Another 30 seconds or a half a minute. Now we're at 1 full minute, right? It's passed. And now we're at 210. Okay. Now the boat takes off, going across the river here. So after 4 minutes, it's kind of halfway across, and it's still at 210. And then after another 2 minutes, it finally makes it to the other side, but it's still 210. And then it takes half a minute for one of the guys to get off, so now it's 140, and another half a minute for the other guy to get off, and now it's back down to 60. So if x is the time, and f of x is the mass, the total mass of the boat. Okay, we got the world's best drawn camel here, and we're looking at the mass of this hump here. So that's going to be our f of x, and we're going to be measuring x here in days. Okay, so the mass of the hump on the at the beginning, when we start measuring, is actually 40 kilograms. Okay, 40 kilograms. Now, the camel maybe does a little bit more eating. It's actually fat deposits in there, not water. So the camel does a little bit more eating on the first day. It increases to 40.8. Okay, so that's after 1 day. Then he goes on a long journey. So after 2 days, he doesn't eat anymore. The hump's actually, so the first day it kind of got a little bigger, and now it's going to reduce, okay, because he's not eating. So after 3 days, actually, not 2. After 3 days, he's at 37.6 kilograms. So that's after 3 days. Now 2 more days, still no eating or very little eating. After 5 days, he's at 20. And after 6 full days, he's really had to rely on those deposits to survive, or at least stay energized. He's down to 2.8. So this hump, by the end of the 6th day, is really almost non-existent. So again, if x is the number of days, and f of x is the mass of the hump. Okay, in this case, we got an empty glass to start. That, before we start the timer, weighs 90 grams. Okay. Now we're going to turn the faucet on and fill it up with water. Okay, so after half of a second, we start the stopwatch. After 0.5 seconds, it fills up some. And the mass of that now is 120 grams. After another full second, so now we're at 1.5 seconds, okay, fills up more, maybe even a little bit more than that, 180 grams. After 1.8 seconds, so a little bit more, now it's at 198, and after 2 full seconds now that have passed, the water, or the mass of the cup and water is 210 grams. So if x, again, is the time in seconds, and f of x is the mass of the cup plus water. In this case, x is not time. X is the length of the side of a cube, okay? And f of x is the mass, is still the mass of that cube in grams. So if we have a cube with length 1, so this one cube here, it's 1 by 1 by 1 on all edges, that's actually going to be 1 gram. Okay, so that one cube is 1 gram. If we increase that side length to 2, now there are actually 8 little cubes that make it up, and so the mass is 8 grams. If we increase it to 3, that goes to actually 27 grams. If we increase it beyond the picture to 4, we're at 64 grams, and etc. 5 will actually be 125 grams. So if x is the length of the side, right, of a cube, and f of x is actually the mass of the cube. Okay, in this case, we're talking about the mass of the shin bone of a newborn baby. Okay, so this is in grams. So when the baby's born, that shin bone, let's say, is 80 grams. Okay, so that's after 0 months. So we're measuring time in months. After 1 month, that bone, grows with the child and is 82 grams. Okay, so that's after 1 month. After 3 months, some more growth has occurred, and now we're talking about 85.5 grams. After 5 months, sorry, that was after 3 months. Now 2 more months go by, 5 months, 88.5 grams. Okay. And finally, after 6, 7, 8 months, we're talking about a shin bone that now weighs 90 grams. Okay. So if x, again, is the time in months, and f of x is the mass of that shin bone. All right, we've got a pumpkin growing here, and they started measuring the mass of the pumpkin at some point in time. Now, after half a month has gone by since they started measuring it, so we're at half a month after they started, the mass of that pumpkin is 26.25 kilograms. Okay. Now, after a full month, they measure at the end of that month, and now it's 30 kilograms even. Okay, so it's grown up. It's gotten bigger. Okay. Now, after 2.5 months, so another month goes by, and then another half a month. Now it's actually decreased, 29.25. Maybe there was frost or poor weather. It's decreased. They check it again. They're concerned after 3 months, and now it's back up to 30 again. Okay. After 4 months, now it's really starting to pick up. Maybe they've given it some Miracle Grow or whatever they do when they go for these records. And now after 5 months, it's up to 78. So now it's really starting to pick up. So again, if x is the number of months and f of x is this massively growing, by the end anyway, the mass of that pumpkin. Okay, we got a snowball here that's rolling down a cliff type environment. So at the beginning, before we start that stopwatch, it's at 20 grams. Okay, now the snowball starts to roll in the snow. So as it rolls a little bit, okay, it gets a little bigger because it picks up snow as it rolls. So after 1 second, we're at 23.8 grams. Okay. Now, after 3 seconds, it gets right to the edge, and it's even bigger now. So now we're talking about, that was after 1 second, now we're after 3 seconds. Okay, time's passing. We're at 26 grams. Okay. But then it rolls off the cliff, and as it falls, right, now we're at 4 seconds. Because of its falling, pieces fall off of it. It actually loses a little bit of mass. Now we're at 25.6 grams. Okay, continues to fall, and by the time it gets here, 5 seconds, it's at 25 grams. Okay. Then it hits again, and down here after 7 seconds, and this is our last piece of data, it starts to pick up snow again. So now we're at 7 seconds, and it's 25.6 again. And after 8 full seconds, it's actually gone up to 28. Okay. So again, if x is the time in seconds, and f of x is the mass of the snowball over time. Okay, in this story, we're looking at a very microscopic amount of time. So we've got a mosquito here that's going to be sucking some blood and then flying away. Now, at 0.1 seconds, okay, so we're talking, this is like in slow motion, right? The mosquito weighs 0.06 grams, tiny little thing. Okay, he's sucking some blood up. After 0.3 of a second, he's gained a little bit of mass because of the blood intake. Now he's at 0.062. 0.4 seconds, he's at 0.063. Okay, 0.5, he's at 0.064. But see, then he flies away, he almost gets swatted. And just like anything that's alive, everything loses weight, if it's not eating or gaining weight. Just by exhaling, you lose weight. So then at 0.6 seconds, just by living, it's down a 10,000th of a gram. And just a 1/10 of a second later, loses another 10,000th of a gram. So if x is again the time in seconds and f of x is the mass of that mosquito,